is the 0.2 kilogram pin. So this pin is inside this groove. It is constrained to move in the smooth curved slot. This is the slot, okay, defined by the R. So the expression for R is given, okay, and the slotted arm, this is slotted arm OA, has a constant angular velocity. Angular velocity can be written as theta dot or omega, so you should not get confused. This is the same thing, that is equal to -3 radians per second. So remember, if this constant is written here, it means theta double dot for a constant. What do you suggest me? 0, because it's a constant angular velocity, so angular acceleration would be 0. Motion in the vertical plane, so it's like not horizontally moving, but it's in a vertical plane. So the question is, find the force of the arm OA on the pin P when theta equals to 0. And look, this is theta. So if I draw this line here, this is the slotted arm, and theta is 0 at this position, so slotted arm will experience. So I would say this is the normal force, this is the vertical force downward, and you know vertical force, gravity, W equals to mass times gravity. In this case, it is. So let's start from here. So if I do the math here, let me show you. This is the radial unit vector, and this is the transversal unit vector. And you guys already know that all the forces along the radial component, there are mass times acceleration in the radial direction. All the forces in the transversal direction is mass times area acceleration in the transversal direction. So what we have to do here, we are mostly concerned about the transversal direction. So, but we will find out radial acceleration, transversal acceleration first of all. So let me go back. How would you find out the radial and transversal? So I'm going to copy this over here. I'm going to use these two formulae. So let's find out what is the formula for radial unit vector. So R double dot minus R theta dot square. So, and for the acceleration transversal, we have the formula R theta double dot plus 2R dot theta dot. So I would suggest you guys start from the first expression, and then first derivative and the second derivative. I would suggest like this. So what is the expression for R? If I go to this formula, R equals to, it's not formula, it's the expression, 0.6 times cosine 2 theta. 0.6 times cosine 2 theta. So I would take the first time derivative. So remember, this is not a function of time, so we have to do the chain rule. Okay, so look, 0.6 negative sine 2 theta, and again you will do the 2 theta dot. So the argument is 2 theta, so 2 theta is 2 theta dot. Agreed? That's the chain rule application. So I wrote down this one. Now the second part is R double dot. This 2 multiplied by 0.6, so negative 1.2 is outside the parentheses, so you're left with sine 2 theta times theta dot. So these are the two variables, u and v. So if I write down the derivative uv, first function to derivative of second function to derivative of the first. This is a general formula. So you can use this formula to answer this. So let me grab this one over here, so and rewrite everything here. So imagine this is my u, this is my first function into derivative of second function into derivative of first function times 2 theta dot. So this is the chain rule application, as well as now you just apply for kinematics. So at angle 0 degree, because the question, if you read the question carefully, we have to do everything at this picture, which is particle is right over here in the slot. So I will make a slot here. So when the slot brings it over here at an angle theta equals to 0 degree, what is AR and what is, this is my concern. So what is AR and what, let's find out what is AR first. So AR equals to R theta double dot minus R theta dot square. Do we have theta dot in our, so we have theta dot as negative 3. So let's open your calculators. So can you find out R double dot and R dot at an angle, R dot at an angle 0 degree? So let's do this over here. Negative 1.2 sine 0. It would be 0, correct? Theta dot is negative. It would be sine 0 is 0. Agreed? And what is R double dot? If you plug in, so this one goes to 0 here. The first term, I will say, let me write down here. First of all, negative 1.2 outside the parentheses. So this 2 also comes, let me make sure this is negative 1.2, 2 times. This is 2 theta, and this is negative 2. So what do you suggest me? So if you open the parentheses, negative 1.2, this is 0 plus, because theta double dot is 0. Agreed? And cosine 2 theta, cosine 0 is 1. So it will be 2 times theta dot square, theta dot square. You agree? Because this is theta dot here. So if you open the calculators and let me know, it is 2.4 times negative 3 square. 9 times 2.4, negative 21.6. Do you agree with your professor? One student agrees, so the other students can also verify this answer. So now we have found R double dot. So let's plug in everything in this equation. 21.6 minus R. We did not find R at an angle. So let me, for that means R at an angle 0. This will be 0.6. You agree with your professor? So 0.6, so you plug it in over here. 0.6 times negative 3 whole square. So if you do the math here, what do you guys find out? AR, is it negative 27? Can you open your scientific calculators in your smartphone? Do you verify? Okay, now let's plug it in. A theta at picture 0 degrees. What is R? You already found R was 0.6. Let's plug it in. 0.6, but it's okay. You see, theta double dot is 0 because it is moving at a constant angular velocity. So theta double dot is 0. So the first term goes to 0 plus 2 R dot. R dot is also 0. Take a look here. R dot is also 0. So the second term also 0. So it means the answer is 0. So when the answer is 0, all the forces along the transversal directions. So if the particle is here, this is upward force, this is the downward force, and this is the normal unit vector. The transversal unit vector is up here. So can you find out ma theta? So upward force is N, downward force is W. You agree with me? And this is the right hand side is 0 because of the transversal acceleration, which is 0. So N equals to W, which is equal to m times gravity. M is 0.2 kilogram. 0.2 kilograms, 9.8. So I got 1.96 newtons. This is your answer. I hope you understand.